All right, so let's take a look at some mole problems. Problem number one that you guys were just sort of looking at. Hopefully that's on the board. Okay. All right, gotta always check. All right, it asked how many atoms of copper are in 32 grams of copper. All right, so we're starting off with 32 grams, and we're gonna put Cu, that's copper. All right, and it wants to know how many atoms. And so we're going to plug atoms over here. All right. We don't want grams, so we're going to go ahead and put grams here. Grams, copper. We know that so many grams of copper is always going to equal a mole of copper. And we don't want moles of copper, we want atoms, so we're going to go ahead and put mole copper here. And this is going to equal to atoms copper. Now, remember, atoms, particles can equal to atoms or molecules, molecule. Okay, so all of those words can be used interchangeably. So that's why we used atoms and atoms instead of particles. All right, so now you're going to look on your periodic table. Your periodic table has, for grams, now we got to figure this out, is 63.5. We're going to round that up to 64 grams, okay? 64 grams. All right, equals 1 mole. Okay, and 1 mole of copper here then is going to equal to 6.02 times 10 to the 23rd. So Avogadro's number. Okay, grams of copper get canceled out. Moles of copper get canceled out. So we're done. We have our atoms, and that's what we're looking for. So now we're going to simplify. We're going to bring our numbers down. So we have 32 times 6.02 times 10 to the 23rd, all over 64. And we're not going to worry about that one or that one. Okay. Well, right now, before anything else, we can reduce. So 32 can go into 64 twice. And that becomes a 1. So this makes it really simple. 2 can go into 6 how many times? 3 times. So let's cross this out. This now becomes 3, and this becomes a 1. So now we end up getting 3. It's actually 3.01, but 3 times 10 to the 23rd atoms. Okay, box your answer. Oh, of copper. Copper. Okay, so that's how we do problem number 1. All right, I'm going to erase it quickly. And now we're going to attack problem number 2. Okay, problem number 2. Starts off with 1.8 times 10 to the 24th. It says molecules. And sadly, you can't abbreviate that word. I don't know why. And it says hydrogen gas. So hydrogen is H2. We want to know the volume. And so volume is going to be in liters. Okay. We don't want molecules of H2. So molecules H2. And we know that's going to equal to a mole of H2. We don't want moles, we want liters. So a mole of H2 equals liters of H2. All right, so how many molecules? Right here, we know it's going to be 6.02 times 10 to the 23rd equals 1 mole. And then 1 mole here is equal to 22.4 liters. Okay, so remember the word molecule. Again, we have particles. Molecules, particles, atoms, all the same thing. We just plug in that different unit. That's all. Okay. Let's bring the numbers down now. Oh, molecules cancels. Boom. Moles cancel. Okay, let's bring the numbers down. We're simplifying. 1.8 times 10 to the 24 times 1, who cares, 22.4, all divided by 6.02 times 10 to the 23rd times 1. Okay, so this is what we get. Now, to really make this a little easier, let's do this. Let's move this decimal back. By moving that back, this becomes 18, and now this becomes 23. So 6 goes into 18 how many times? Well, we know it goes in 3 times. So this is a 1, that's a 3. And then 10 to the 23rd cancels out, cancels out. So we really have 3 times 22.4. If you crunch that in your calculator, you get 67.2 liters of H2. And bam, we're done with problem number 2. Do you see how simple and easy stoichiometry is? This dimensional analysis that you guys have been doing all year long is the exact same process. Please always use this process because the steps are very, very similar and they help out. Okay, problem number 3, last one. All right, you're given 44.8 liters of hydrogen sulfide, and you want to know the mass, and the mass is in grams of hydrogen sulfide. Okay, we don't want liters, so liters, H2S. We know that's going to equal a mole of H2S. We don't want moles, so we're going to put mole H2S. And we know that a mole of H2S equals so many grams of H2S. Okay, so how many liters of hydrogen sulfide are there in a mole? Well, we know it's going to be 1 mole. And there is, when we're talking about liters, 22.4. It's just a regular standard number. You got to use it. Okay. Is that many moles, or that's equal to 1 mole. Okay, now 1 mole, and we've got to now look up hydrogen. Hydrogen's going to be 1, but we have 2 of them, and sulfur has an atomic mass of 32. So sulfur is 32 plus 2, so we get 34. So 34 is our grams there for 1 mole. All right. Let's cancel out our liters. Our liters cancels out. Our moles cancel out. And now we're left with grams there. Okay, let's now simplify it. Let's bring our numbers down. 44.8 times 1, who cares, times 34. All divided by 22.4 and 1. No big deal. Now, if we see a relationship here, we have 44 and 22. Well, 22 can go into 44 twice, so we get a 2, and we get a 1. 2 times 34 is 68. Notice I don't even need a calculator here. Look how fast that is. 68 grams of hydrogen sulfide, and that is how you do problem number 3.